Hello everyone. In this video, I'll share my experience about integrating Edge Impulse into nRF5 SDK. So, to give brief information, if you are not very familiar with it, Edge Impulse is a machine learning tool. If I'm not mistaken, it's oriented towards embedded systems and nRF5 SDK. So let me show it here. This is the folder of it. It is a software development kit for programming Nordic semiconductor microcontrollers. So there are two software kits actually, nRF5 SDK and nRF Connect SDK. So in the nRF Connect SDK, Edge Impulse is already supported there. So you can get the official instructions from internet. As for nRF5 SDK, there is no information about how it can be used. So that's why I decided to share with you what I managed to do so far. Okay, let's start. So in order to make it clear, I will do this video in a demo style where we first make a project without using Edge Impulse, a plain project, and then we'll make it work. I'll explain you the idea of the project, and afterwards we will try the same with Edge Impulse, and I'll show you all the steps and the reasoning in this process. So let me first tell you about the hardware that I'll be using for this video. So I'm using nRF52 development kit. It's quite popular. So that's it. And I mean, yeah. So in embedded systems, as you probably know, you usually have various sensors. It could be imagery sensors, audio sensors, motion sensors, and etc. And what we usually do, we write our own algorithms to interpret the sensor data to do something useful or to infer something useful. And it turns out that in such applications, machine learning is quite strong for these purposes. And sometimes as a programmer you may not be able to achieve very high results, and so in some scenarios it may be wiser for your application to try Edge Impulse. And so why don't you do it in nRF Connect instead of nRF5 SDK? Because in nRF Connect you wouldn't need my instructions actually, and Edge Impulse could be easily integrated. So the problem is that for some products, so maybe you have already manufactured your hardware and your customers have it, and you would like to add additional functionality by using Edge Impulse. Perhaps it will increase accuracy of your device, or another alternative. Let's say you've been working on a project for a couple of years and it is based on nRF5 SDK, and you may be close to production, and so at this point you cannot change your software development kit because it would be too much work to change your project. They have different API. So in these cases this tutorial will be useful for you. And so what is the project? So this is the idea. Let's imagine that there is a light detection sensor and it receives the sunlight, and according to the intensity of the light it will generate an 8-bit output. So values ranging from 0 to 255, where the 0 would be total darkness, and it would correspond to total darkness, and 255 would be the maximum intensity. And then you would have a microcontroller, which will be a development kit in our case, which receives the sensor data. And then here we will have an algorithm. Firstly, we won't be using machine learning. It will be algorithm based on threshold values. So where we would compare the sensor readings with the threshold to tell if the weather outside is sunny or dark. Okay, for example, I would take a threshold of, let's say, 230 and compare it to this value sensor reading. If sensor reads 100, I would say, okay, it is dark, it's cloudy outside, it's not sunny. And well, if it's above 230, I would, in that case, I would turn on this LED to indicate it. I mean, that's all of the project. And so I mean, the purpose is to make a development kit sufficient for this tutorial, so you won't be needing any actual sensor. I mean, we will simulate the sensor readings through button presses. So these 4 buttons, okay, we will assign them predefined values. Let's say 100 for this button, 200 for this button, and etc. And according to this sensor inputs, so-called sensor inputs, we will turn the LED here. So I mean, the development kit is sufficient for us to conduct the whole project. And after we make it work, next step would be to generate a project here on Edge Impulse website. So we will prepare some data to train machine learning model, to test it, and with all other steps that are required. And in the end, we will run the development kit and with machine learning mechanism in microcontroller this time. So once you would push these buttons and feed sensor values to your program, this time these values wouldn't be compared to a threshold as in the initial implementation. They would instead be classified by your machine learning. Okay, that was introduction. In case you are already familiar with building the, I mean, using Edge Impulse website, building the models and etc. You can skip to future sections in this video where I show in detail steps needed just to integrate the Edge Impulse source code and the model, or you could just follow all the steps to see the picture. Okay, let's start doing the project. So firstly, we will do it without machine learning. Let's head over nRF5 SDK, go to examples, BLE peripheral, and copy the Billy app link example here. I will open a separate folder where we will be working. Let me call it project. I'll paste the example. So let's open it with Sega Embedded Studio for simplicity. Okay, I'll remove all of the code here and paste here the code that I have written myself, and I will explain it to you now. So this code has only these headers and this function from the original code. So the headers are required for logging, and here we have the function that initializes the logging module. Okay, so we have two headers here for dealing with inputs and outputs, and for enabling using delays. These are five pins that we are using. So these four are input pins that would simulate the sensor reading by button presses, and the LED pin. These four are the predefined values that I've told you about. So if you would to press button 2 value, button 2, you would simulate a sensor reading of 220. Okay. The threshold value is the one that will be used in the algorithm. So let's say you press button 3. Okay. Then a value of 235 will be fed into your program, and it will be compared with 230. So since it's above the threshold, we will turn the LED on and tell the user that it is sunny outside. Otherwise, let's say if you press button 2, this value is below the threshold, and in this case you would turn the LED off. Okay, so we have three initialization functions here for logs, for LED, and for button inputs. Now what happens in the main loop? So we have infinite loop here. It is constantly polling the input pins, the button input pins. Once any of them is pressed, it will go to the appropriate part here, and what it will do is that it will print this event. Then it will pass the associated button value, I mean the sensor reading, to our algorithm, and we will just add a delay here so it works. And lastly, the process input function here. So well, it is actually very simple. Well, it compares the value with the threshold, as I've already told you. So if it is below the threshold, we turn the LED off and print something in console, and otherwise, if it is above the threshold, we'd say that it is sunny and turn the LED on. So one thing that you may notice here is for turning the LED on here, I'm using this function, GPO pin clear, which sets the output pin, the LED pin, to low, to 0, but it turns the LED on. I mean, this is not a mistake. This is how the LED on nRF52 development kit works. I don't know the underlying logic. Maybe they are using P-channel MOSFET there, maybe something else, maybe an inverter. I don't know the details, but that's how you turn on and off these LEDs on the kit. So, and apart from that, let's go to SDK config, open the CMSIS config here, and we will do some modifications in the nRF log part. So I will enable Seger RTT logs, I will disable UART, and over here there's an option called nRF log deferred. I will unselect it and save it. So let us compile the project. Okay, now the project is compiled successfully, and what we will do is following. So let me show you the development kit here. So these are 1, 2, 3, 4, the 4 buttons that we will be using to generate the sensor reading, and the one flashing here is the LED used by our program. So I will go to build and debug, and start program. So pay attention to logs over here. Okay, so let us start by pressing button 1. You see the LED 1 is off because the associated sensor reading is below the threshold. Now I'll press button 3. The LED is on now, and the logs in the console are telling that it's sunny. So let me press button 2. It's not sunny. Button 4. It is sunny. So the project is working, and by using it as a reference, we will build up on top of that to make the assessments to the sensor reading, but this time with by using machine learning. Okay, let's start doing edge impulse related stuff. So this is the blank project here, and our aim is to train a machine learning model. And for this purpose, we need to provide two data sets. First data set would represent sensor readings from the times when it is sunny, and second one would be from the sensor readings when it was not sunny. And I've created these files. So if you click here, there are many ways you can provide the data, and over here you can see that CSV format is supported. In other words, you can use Excel spreadsheets. Let me show you the training data now. So I will open it, Notepad. So both of them have two columns. First column is time related data, and second one is sensor readings. Since we do not have actual sensor, all of the sensor readings are simulated. So for not sunny data or dark data, as I called it here, the sensor readings are random values between 0 and 230, and if you pay attention to these values over here, you can see that they match this description. And for sunny data, these are random values between 230 and 255. You see all of them are in this range, and we have overall about 200 samples for training data. And in the timestamp column, these units are in milliseconds, so the interval between each sensor reading is 1 second. Okay, so the last value here is 200,000, so it means 200 seconds. While we are discussing the spreadsheets, I also wanted to cover two other files that I have created, these two files. So once we train the model, we will need to verify its accuracy. So I created two files to check how accurate is our model. And it is easier to create testing data. We know that all values between 0 and 229, they correspond to dark weather, and 230 up to 255, they correspond to sunny data. So once you pass any of these inputs to your machine learning model, you expect that it will classify this sensor reading as one corresponding to sunny weather. So if it does that, it means your model is good. Otherwise, you have a problem. Okay, let me close them, and I'll go back to Edge Impulse, and we will upload training data first. So let me select the first file. So training data for not sunny. I will select that it's training, and I will enter a label called dark. Upload it. Okay, we will do the same for second data set. I'll call it sunny. Done. Now go to impulse design. I will keep this one as default. Here I will choose raw data. Here I will choose this one. Let's click Save Impulse. Go to second step. You can visualize your data. So for dark data, you see it is indeed random values, sensor readings between 0 and 230. And for sunny, they are all above 230 here. So we'll click Save Parameters here and generate features. By the way, I'm not an I don't know very good machine learning related stuff, so yeah, just wanted you to know I may make mistakes in some machine learning stuff. So this is the window where we will train the model. So I played with these values, so I will make it 70 and remove 1 0 from here to get usable results. Okay, this is almost finished. Okay, it has about 90% accuracy. That's fine. So let's go to model testing. Even though it's not mandatory for our tutorial, just want to show you the results. So I will upload the testing files. So for dark values and for sun values. Okay, I will click model testing again and click classify to see how good is our machine learning model with the reference data. Okay, it has, I mean, its accuracy is okay. Now we are almost finished with the Edge Impulse website. So last thing that we need to do is to go to deployment. Select C++ library. Here, make sure to use int8 option here. Otherwise, the memory of the library may be too high for your microcontroller to store it. So I'll click build. And yes, we are finished and we generated, I mean, think of it as your machine learning model. What we will need to do is we have to find a way for it to work inside nRF5 SDK inside our project, and we will do that later. Okay, here is the C++ library that was generated from Edge Impulse website. So let me create a folder here. I'll call it Edge Impulse, to which we will move all these files. So we do not need CMake lists, so we will move just the remaining 3 folders. Okay, now let's go to our example here. Let's enter the Blink example, and I will just move all Edge Impulse stuff right over here. Now, Edge Impulse library is present inside our example. Our next steps will be to change our project settings in order to utilize it. Okay, now that we have Edge Impulse folder here, so I want you, before moving on with changes that I am going to do, so I want to explain you why I'm doing it. So Edge Impulse library, it may need to print something to the user. So let's say it wants to print classification results, or another example, let's say it needs to dynamically allocate memory for its internal uses, and Edge Impulse library, it is not aware where it is being run. So for instance, you may run Edge Impulse on a Nordic semiconductor microcontroller, or you may run it on microcontroller by Texas Instruments, and each of these microcontrollers have different function calls for printing stuff or for allocating memory. That's why Edge Impulse, what Edge Impulse developers did, they wrote wrapper functions, and for each platform, the implementation for this wrappers has to be made. So if you go to Edge Impulse SDK, so you see there is a folder called porting, and it serves this purpose to port it to different hardware. So you can notice Zephyr folder here, and thanks to this folder, nRF Connect SDK is supporting Edge Impulse. I mean, that's why they work together. And here you can also see the other platforms that support Edge Impulse. So let me show you an example. So let's go to Arduino. I will open it with VSCode. Let's say if you have been working on Arduino, you probably have used this function, serial write, to print stuff over UART. And so this is the wrapper. If Edge Impulse wants to print something for Arduino implementation, it will use the serial write function. Okay, and since we do not have any implementation for nRF5 SDK, we will have to do it manually. And for this purpose, I'll go to this folder, copy these two source files, and let's paste them here. And we will rewrite them so that they work with nRF5 SDK. Okay, let's start with the header. For header, these are all the wrappers. Okay, and here are defines which specify where it is being run. Okay, and since we have none of them, I will just completely remove this part up to this point, and we are good with the header. I mean, it is only thing that should be changed in the header, or perhaps you can make some modification to existing code and be fine without changing anything. Okay, about the source file, the implementation of these wrappers. So first thing that we need to change, you see we have include, so because I moved the files to the same directory as the header, they share the same directory. Okay, so the source file, for including the header file, we can remove this. Then there is a define, checking if it is this implementation. I mean, we do not need this, so there is one more line in the end. So I moved it. Okay, now let's go over all of these functions and see what needs to be changed. So this one is not doing anything at all, so we'll skip it. There are three functions here. This will put your device into sleep. These two are for getting time in microseconds and in milliseconds and microseconds. And what I will do, I will just comment them out, and I will explain you why. So let me comment them. So these two functions, they need to return something, so I will just return 0. Okay, now about why I have done that, there are different reasons. First reason is that they are not critical in using Edge Impulse. If I'm not mistaken, they are more inclined towards debug information. I guess that's why we need read timer functions here. And for sleeping, frankly speaking, I don't know why Edge Impulse needs it, but I didn't encounter any problems when I disabled it. If you want, you can later fill these functions by yourself, but I mean, you should know that adding them may have consequences, not from the point of view of Edge Impulse, but for your own application. So let's say if you own Edge on nRF5 SDK, in order to track time, you will use some library or hardware that will increase your current consumption, or it will generate interrupts if you want to use millis. So perhaps maybe you do not need it. So I thought it's best to comment them out and to increase your confidence that this is okay. So let me show you implementation of Texas instruments. Well, let me open it with Notepad. So for example, if you look into their function called Edge Impulse read timer microseconds, you see they just bypass it. They do not do anything, and the reason is because their board hangs when trying to call it. So in my understanding, they are not critical. It's okay to bypass them. Let me close it. So we are done with these three functions. We have two functions here responsible for printing stuff. I will comment them for now, but we will cover them later. Actually, we'll cover them in the end of the tutorial. Let's bypass them for now. And for memory allocation, the default ones used here are okay. In nRF5 SDK, there are other ways to allocate memory. If I'm not mistaken, there is a function called nRF5. So if you have to use it, you can use nRF5 here instead of plain malloc and include the associated header over here. But for our example, this way is okay. And regarding the headers, here most of them are unnecessary at the moment, so we need stdlib for using malloc and etc. So I will keep that one, and since we have int32, uint32, etc., I will include stdint here. And we are done with the header for now. The only thing remaining for later are the print functions. Now we have the last file called debug log cpp, so it has also a macro check here, so let me remove it. It also have the path issue here, so let me remove it because they share same directory with the header. And it calls Edge Impulse printf function, so I will comment it for now as well. We will fill it in later when dealing with logs. Okay, we are done with the porting, and let's move on to the next steps. Okay, now that we are finished with porting, I want to show you something else. So in the Edge Impulse SDK folder, if you go to TensorFlow, you can notice something special here. There are files that have .cc extension. Okay, these are C++ files, but their extension is .cc. So this is a problem for us because the ARM GCC compiler that we'll be using will give errors when trying to compile this file. So what we will do is following. I will just copy the TensorFlow folder path to the TensorFlow folder here. I will open the command line. Let's go inside it, and there is a script that I found on internet for renaming file extensions. So all it does, it replaces .cc to .cpp for every file inside the folder. So I will just copy it, and yeah, let's just start it. Okay, now if I go back, you see it renamed all of them to .cpp, and we are good to go. Okay, now we will do following. We have done already a lot of modifications. Now we will do changes into the Makefile. We will build our project and Edge Impulse together using Makefile, not Sega Embedded Studio. And in order to understand what changes need to be done into the Makefile, we will use some examples. I have two pages open on my browser. Both of them are repositories belonging to Edge Impulse. So first one is called example standalone inferencing, and second one is inferencing with the Zephyr. So what it is actually is this is a C code that is required to run your Edge Impulse library on your computer. This is the same, but to run it on Zephyr, maybe on nRF Connect SDK, I guess. So I copied both of these repositories to my desktop, and we will use them as reference. So let's do following. I'll open my SDK. Let's go to our project, open it with Visual Studio Code. Okay, so just let me show you where the Makefile is. So this is our example. Go to PCA 140, and we have ARM GCC folder and the Makefile here. Okay, so you see for building the example, I mean, it already has all the source files of nRF5 SDK for printing and everything else. Now we need to add source files that are required to use Edge Impulse. So let's start. The first thing, we need to add path to the Edge Impulse folder. So if you let me open the project here. This is the project folder, and the Edge Impulse folder is right here. So I will do following. So let me copy and paste it. I will call it Edge Impulse directory, and the path to Edge Impulse directory is following. Okay, this is done. Now we need to add the source files. For that purpose, I'll go to the C example, open the Makefile, and here these 4 lines are the source files required to run Edge Impulse. So let me firstly just copy and paste them into our Makefile. Then we will modify them according to our needs. So I will remove these assignments, and I'll take it will take 1 minute. Just let me format it so that we can see what is what. Okay, now let's start from the end. So this one is to include source files inside the source folder. So if you go to the example, here is the source folder, and this is just the main.c. Since we have already our main file, we do not need this one. I'll remove it. Next thing is, if you remember, we renamed the CC files into CPP inside the TensorFlow folder. So I will change this .cc's to .cpp. We do not have .cc's anymore. Next, these two lines have porting stuff. We already wrote our porting, so I'll remove them and add source files that we created. So let me copy and paste this line for reference. Our porting code is inside Edge Impulse SDK porting, and these are the CPP files, two CPP files that we need to include. So I will do following: Edge Impulse SDK porting, and second one is called debug logs.cpp. Okay. Next, if you notice, for these two lines we have dot and slash. I don't know what was their purpose, but I removed them, and we need to provide path, full path. We need to add this directory name in front of all of these source folders. So I will do this. Okay, and lastly we have line separators here, so I will add them as well. After this, we are finished with the source files. Okay, great. Let's continue. The next part inside the Makefile are the includes. For this one, unfortunately, I do not have a very fancy implementation. I will add the whole directory to the include. I mean, I know that it's ugly, but I do not know what needs to be included, and I didn't have much time to find each of the headers separately, but we can improve this later. But it works this way. Let's continue. We are done with includes. Here we have compiler flags, and what we will do, for Edge Impulse to work, we will add 5 flags, additional flags. So let me add this 5 as templates, and I will explain which flags needs to be added. So in the C example Makefile, you can find 3 flags over here. So let me firstly copy and paste them, and I will later explain them. This is the first one. This is the second one. And this is the third one. The last two I will tell about them as well a little bit later. So these two I'll cover later. So this one, it is for disabling neon features on some processors. I believe this flag here is not critical, but I disable it for any case. I don't have much knowledge about this one. These 2 flags are critical. So what they do is following. So the library that you exported from Edge Impulse website is a C++ library. By enabling these two flags, you compile Edge Impulse API as C. So in nRF5 SDK, we usually have C code, not C++ code. So it is better for us to work with C files. So by enabling this flag, you solve many of the integration problems. If you do not do this, you may run into problems. Or actually, you will run into problems because let me show you an example here. So this is the C example, right? So if you go to C++ example, and let's check its main file. It is a template showing how to work with Edge Impulse API. Okay, and if you notice here, for instance, they have standard vector from C++ template library. So this means that if we will not change these two flags, then we will need to add standard vector into our main.c in nRF5 SDK project. So it may cause a headache for you. So this is the best way. The reason why they have these two flags for Edge Impulse, because actually some of microcontrollers may not even support C++. So this is for that purpose. Now, earlier I was able to make the project work, Edge Impulse work, just with these three flags. But on some occasions later, I found out that the projects, some exported projects, are not working. So it took me a long time to find out, find the solution for it to work. And it is following. So apart from the C example, let me show you the Zephyr example here. Sorry, I need to go to this file, cmake. And here you can notice there are some additional flags. They are related to CMC's DSP and CMC's neural networks features. So what are these? So let's read it. This line: use hardware acceleration for DSP and neural network code. And it turns out that the ARM processors that are being used on Nordic microcontrollers, they have hardware acceleration features that are actually useful for Edge Impulse, and by enabling them, you may accelerate how your machine learning works. But the thing is, according to my knowledge, I may be mistaken. So if you go to the nRF5 SDK components toolchain, so you can see you have CMCs here. It is responsible for DSP stuff. And as I know, this hardware acceleration is not being utilized by default. So our Blinky example is not using it. So in other words, the Edge Impulse library that has been generated may be using these DSP features. It may think that, okay, hardware acceleration is enabled, but since our example do not have these features, so at some point you may get an error. This is my understanding. I may be incorrect, but that's how I understood. Please correct me if I'm wrong. Not just about these two flags. I would be very glad to hear some feedback about overall process. So what I will do, I will add these two flags. Actually, let me copy them separately and let's paste them. Okay, and I will disable the DSP stuff. I will disable hardware acceleration, so we will not get any errors here. So up to this point, we added 5 flags here. We added the header, so-called header, and the source files of Edge Impulse. Next thing that we need to do, so here we have the W error flag. I will comment it out. If you keep it enabled, Edge Impulse will crash. It will not. It won't get compiled. I guess the best way is to include Edge Impulse source files as system files. I guess this way you can suppress their warnings and keep whatever flags you want in your main project. I tried it, but it didn't work, unfortunately, so I will just disable it for now. And lastly, in the C example, you can see that these are two library related flags, -lm and this one here. So if you go to our project, in the bottom of the Makefile, here you see we have this kind of includes here. We already have -lm, so I will just add this one here. And I believe we are finished with Makefile. So we changed libraries, we removed the error warning flag, then we added this one, then we added 5 flags over here, and we dealt with adding Edge Impulse directory, the source files, and the header. Okay, now that we are finished with the Makefile, we will do following. So this is our example. Before going on here, I would like to show you following. So this is the C example by Edge Impulse that shows you how to use Edge Impulse with C code. Okay, and what you should do is you need to go over this example. Actually, you can run it on your computer. You do not need microcontroller for that. You need to understand the API, how to utilize the library. And so what I did, I went over this and then modified our project main.c accordingly. So let's open our project here. Actually, let me open it with Visual Studio Code for simplicity. Okay, and here we have main.c. Let me start from the top. I copy and pasted the headers from the C example. I removed our old define for the threshold define because we do not need it anymore. So this one is important. It is an array. It is input array. Okay, it holds all of the sensor readings that will be fed into our machine learning model as inputs, and according to it, machine learning model will make classifications. So these two are also, I copy pasted them from the example. These are required, and all the remaining changes are here in the process input function. So earlier here we had a threshold comparison. Now instead we do some stuff related by required by Edge Impulse. Okay, we fill the features array with sensor value, and then I run the run classifier function, which makes the classification. Okay, so and this is the part where we are checking if it is sunny or not. So let me, in order to understand it better, what is it? Let me show you something. So inside the Edge Impulse folder here, if you go to model parameters, let's open this file here. So it shows that we have two categories here, dark and sunny. So in the main file here, so the first element is dark. Second element, if we would write one here, it would show classification results for sunny label. Okay, but we'll be using dark for now. So the value here can be between 0 and 1. So if we would paraphrase this line here, it is following. What are the chances of this input to correspond to label dark? If these chances are above 50%, then let's turn off the LED and print appropriate log. Otherwise, if this condition is not true, then it means that there is more than 50% chance that it is sunny outside. So then let's turn the LED on. Okay. Now, what I'll do, let's go inside our project here. I will enter PCA 140, S132, and let's enter the ARM.gcc folder where Makefile is stored, and I will call the make function to build the project. This compilation will take about 5 to 10 minutes because there are too many files inside Edge Impulse. Okay, compilation is finished. So we have the hex file here. So let me actually show it to you. So if you go to the build folder here, so this is the hex file. Now let me open nRF Connect, and I have the nRF52 development kit connected to my computer. I will flash our hex file, and also I'll flash soft device because this is a BLE example. It requires soft device to run. So let me check our add our device. This is soft device. Let me actually show you where it is stored. So in nRF SDK, go to components, soft device. Here we add soft device. Then let's go to examples folder, our project, PCA 140, ARM.gcc, and here we have the hex file that is generated. I'll erase and write. Okay, now the example is being run on the development kit. So these four are the values, button values. So if we press button 1, the input is 150, and for remaining 3, 220, 35, and 45 respectively. So let's try our device. I'll press button 1, LED is off. I'm pressing button 2, on, button 3 on, button 4 on, again button 1, it's off. So it turns out that our machine learning model thinks that 150 corresponds to dark, and these three values that they indicate sunny. Given that we did not put much effort into generating our machine learning model, these results are okay, and it's working. Now that we have the application working, the next important things is that we should be able to see the logs. We should be able to debug our application, and since we are not using Seger Embedded Studio, so we should be able to do it in Visual Studio Code, for example. So I actually did a separate video tutorial about using nRF5 SDK and Visual Studio Code. You can find it on my video channel, but this video is long. So what you can do instead, go to this repository here, nRF5 SDK VSCode. Inside it, you can find the folder here called .vscode. It has several JSON files. and what we will do is we will move this folder into our project, and that way you'll be able to debug and see the logs. So I have the repository here. I will copy this folder, go into our project, paste it, and let's open the project from here with Visual Studio Code, and make sure that you have Cortex Debug extension installed. So let me show you this one. Okay, now because of the JSON files that we have here, two things changed. First thing is here in terminal, if you click run task, you can do various stuff. You can build your application, erase your flash your application, and second thing is you can debug and see the logs here in the console. So let me click start debugging. Since we have already compiled the project manually, it won't take long. Okay, now if you go to terminal, over here you have a window called RTT channel 0 console. It will show the logs. I will start the application. Now on my nRF52 development kit, I'm pressing button 1. You see the logs. Button 2, button 3, button 4. So it's working. Now, actually, I wanted to add Edge Impulse into Seger Embedded Studio instead of Visual Studio Code, but I was not able to do it. I will talk more about it in the end of the video and about what possibly could be done to make it work. But for now, this is the only way, at least for me, to use Edge Impulse and nRF5 SDK. So I had to use ARM-GCC, and that's why I should debug and see the logs over here as well. Okay, the last thing that we need to do is following. So let's go to Edge Impulse folder, Edge Impulse SDK, porting, and let's open these files that we were writing with you. So if you remember, we skipped logging part, right? So if Edge Impulse wants to print something, currently it has no way to do it. So I've already filled those. We added 3 headers here. These 2 are required, and this is to interface printing API of nRF5 SDK. Then in the print, we have 2 functions to fill over here, printf and printf float. So for the printf float actually calls this function. So and for printing floats, so this is from DevZone. I just borrowed this information. This is how you print floats with nrflog info. So I just obeyed these rules here, nothing special. And this implementation over here I borrowed from other platforms. Many of them have this kind of implementation. It uses periodic arguments, and in the end it delegates the printing to nrflog info. Okay, so let me start debugging to show you how it works. You will be able to see all of these changes in the GitHub page of this tutorial. So almost finished. Let me open the RTT console here. I'll start the program. Let me press button 1. you see we have additional stuff now. Button 1 is pressed. This is coming from edge impulse. This is coming from there. This is the predictions that it prints. And this is our code. So it works. So what I did, I added these 3 headers and rewrote printf and printf float function here. And in debug log cpp, I uncommented this line, and that's it. Okay, now we are finished with implementation details. So I would like to summarize everything we did so far and talk about a few points. So I created a GitHub repository. It's private at the moment. I will make it private soon, public soon. So in this repository, so we have you can find the CSV files that we used for training, and in the commits section, all of the things that we have done so far, you can see them in the same order. So we added the BLE example. We made our threshold implementation. So these are CSV files. They generated edge impulse C++ library we added here. These 2 commits are for the porting functions. Then we used a script to rename .cc files to cpp in TensorFlow folder. We edited the Makefile. We rewrote our application to use edge impulse. Then we added JSON files to enable logging and the debug process inside Visual Studio Code. And lastly, we fixed edge impulse printf functions. So this is summary of everything we did. Hopefully in following days I will fill the README section here with useful information, and I wanted to make some notes about what can be done, what can be improved. So as for Seger Embedded Studio, so I tried adding edge impulse source code there, but I had difficulties getting it compiled. I guess maybe I am not very proficient in Seger Embedded Studio, but I believe that it has difficulties compiling a standard template library, C++ features, some C++ features. So I think the best approach for using edge impulse with Seger Embedded Studio is following. So I think we need to compile, first we need to compile it through ARM-GCC. And ARM-GCC has no difficulties dealing with both C and C++ code. Then once a project is built, we have a bunch of object files, and we can include the object files to Seger Embedded Studio project. And this way Seger wouldn't need to compile any C++ code. It will just use the objects directly. So the only thing required by Seger Embedded Studio is to fix the include directories. I mean, I tried it, no success until now. I had difficulties with includes. Actually, apart from Seger Embedded Studio, so in my implementation, if you remember, in the Makefile, the include. The way I handled includes is not good as well, so it needs to be improved. And maybe if some of you are good with Makefiles, yeah, I would be glad to hear if there are better ways, maybe to combine all of the object files belonging to Edge Impulse into a single library. Also, how can we suppress the warnings belonging to Edge Impulse calls, I mean internal Edge Impulse implementation. So these are the weak points at the moment in this implementation. And naturally, it would be great to hear feedback from Nordic Semiconductor team and from Edge Impulse team, since I mean they know their platforms better than I. Yeah, maybe they can spot problems or give some suggestions. So I guess that's it. I would be glad to hear any feedback or your suggestions for improvements. If you have something in mind, please share it. So I also want to learn it. Okay, thank you and have a nice week.